So hello again. So this is a continuation of the Kirchhoff's law. Okay, so this is a different solution. Okay, we're going to use the node voltage analysis in solving for the voltages and current. Okay, so we have the same figure as the first, the same problem. Okay, we're given two voltages, two power sources, and three resistors. Okay, so this is the node voltage analysis method. Okay, so first is same steps. Determine their charges. So this positive, negative, positive, negative. So going this way is negative, positive, negative, positive. So going back, it's positive. Okay. In this loop, negative to positive. So we have negative, positive, and then negative, positive. Going back, it's still positive. Okay. So we're going to solve for I1 and E1, I2 and E2, and I3, E3. Okay, so we're going to solve for the voltages of these resistors and their currents, the current that flows through them. Okay, so first is we're going to determine the equation for the current. Okay, using Kirchhoff's current law. So again, it states that a current entering a junction or node is positive while a current leaving a junction or node is negative. Okay, so in this case, I1 and I2. Okay, so they're entering this node here. Let's say this is N. Okay, your node N. Okay, so they're entering this one. So they're both positive while I3 is leaving the node. So it is negative. So again, it is I1 positive plus I2, which is positive again, and minus I3 since it is negative is equal to 0. Okay, so again, I1, I2, they are positive since they're entering the node, and I3 is leaving the node, so it is negative. So just arranging it, okay, it becomes I3 is equal to I1 plus I2. Okay, so transposing yung I3, so it becomes positive. Okay, now we go to the loops. Okay, so in loop 1, okay, so negative to positive, this direction. Okay, these are loop 1 and here negative to positive. These are loop 2. Okay, so using the charges here, so 18 is positive. Okay, so 18 is positive. Okay, positive. And then going up, it is negative. So E1 is negative. So that is minus E1. And then going down there, negative for R3. Therefore, E3 is negative. So that is E3 negative is equal to 0. So this is Kirchhoff's voltage law wherein the voltages, algebraic sum of the voltages of a closed loop. Okay, here. Closed is equal to 0. Okay. Now let's try the second loop, this one. So here, positive, so 24 volts is positive. I'll be writing the units later since we're talking about voltage. Alam naman natin, the unit is volts. So dun sa file answer ko nalalagay yung unit na volts. Okay? So 24, then going up, sorry, going up is negative. So your E2 is negative. So minus E2. Then going down again, so R3 negative, so your E3 is negative minus E3, that is equal to 0. So I repeat, here positive 24, negative E2, and then negative E3. So there. Now we have three unknowns. So this is called the node voltage analysis. Now, so we're going to solve for the voltages. But we're going to use the formula or the first equation, which is I3 is equal to I1 plus I2. So we have only one formula, but we have three unknowns, E1, E2, and E3. So hindi pwedeng solve ng ganun. So you cannot solve three unknowns in one equation. Okay, so pwede pa yung three equations, three unknowns, but one equation and the three unknowns di pwede ma-solve. So we're going to use these formulas. We're going to find a way so wherein isa lang yung nawawala, wherein we're looking for just one variable. Okay, in this case, pareho silang may E3. So we could solve E1 in terms of E3 and we could solve E2 in terms of E3. So ibig sabihin, isa lang yung nawawala. Okay, so we could use that. One equation and one unknown. Okay, so for E1, transposing E1 here, so negative E1 becomes positive. Okay, E1 is equal to 18, so nothing changes here, minus E3. And here, transposing E2, so E2 becomes positive. E2 is equal to 24 minus E3. Okay, so meaning we could solve E1 in terms of E3 and we could solve E2 in terms of E3. So isa na lang yung nawawala. So isa lang yung variable natin kasi sa equation na pwede natin gamitin. Okay, now let us now use this formula. Okay, now E1 plus E2 is equal to E3. I think it would be written as this one. I1 plus I2 is equal to I3. So that's the same. Okay, so para mas magandang tingnan. Okay, magkakasunod-sunod sila. Okay, now we're going to change the values. Now remember that E1 is equal to, I1 is equal to E1 over R1 and I2 is equal to E2 over R2. This is from Ohm's law. And I3 is equal to E3 over R3. Okay, now we're going to change the values. Okay, so E1 here will become 18 minus E3. So, substitute natin yung value na nakuha natin dun sa loop. Okay. So, your I1 now, there, I1 is E1, which is 18. 18 minus E3 all over R1. Your R1 has a value of 3 ohms. Okay. Then plus, so this is your I1. Okay. Plus I2. So, I2 is E2 over R2. But your E2 now is this value. Substitute it with 24 minus E3. So I2 now becomes E2, which is 24 minus E3, okay, all over R2, which is again 3 ohms, is equal to I3. Your I3 is E3 divided by R3, which is equal to 6 ohms. Okay, so I think that's clear. Now we're going to get the LCD of this value. So there's no problem here, 3 lang yan. Okay. So 3 divided by 3 is 1 multiplied by the numerator. So 1 lang naman. So numerator will retain. That is 18 minus E3 plus 3 divided by 3 is still 1 multiplied by the numerator. So walang problema, 1 lang. So 3 divided by 3 is 1 multiplied by 24 minus E3. That's still 24 minus E3. That is equal to your E3 over 6, which is equal to I3. So 6. E3 over 6. Okay. Now, we could combine and then we could cross multiply. Okay? So, magiging, pwede mo naman i-cancel dito. We could cancel this one. Okay. Para walang cut. Okay? So, this is 18 plus 24. That is 42. Okay? So, I'll write it here para magkasya. Okay, 42 plus, minus. It is negative 1 and negative 1, so that is negative 2 E3, okay, divided by 3. Okay, now I'm going to cross multiply 6 here. So E3, so 6 will be cross multiplied here. It multiplied by 6, so we could cancel 6 and 3. Okay, so this becomes 2, then this becomes 1. Okay, so then 2 multiplied by 42, that is equal to 84. Minus 2 multiplied by negative 2, that's negative 4, E3 is equal to E3. Okay, so transposing this one here and 84 the other side, we get negative 4 E3 minus E3. Okay, so this becomes negative. Is equal to negative 84. Okay, so we have negative 5 E3 is equal to negative 84. So E3 therefore is equal to negative 84 all over negative 5. Okay, so I'll use the calculator to be sure. So it is negative 84 or 84. Cancel naman yung negative sign. Okay, 84 divided by 5. So that is equal to 16.8. So you're hopefully you can see it here. Dito lang sa taas, no? So your E3 is equal to 16.8 volts. Okay, you can see that. Okay, now your E1, sorry, E1 is equal to this. Okay, E1. Okay, so it is 18 minus your E3. So it is 18 minus your E3, which is equal to 16.8 volts. Okay, so your E1 now is equal to 1.2 volts. And your E2 is equal to this one, 24 minus E3. So it is 24 minus your E3, which is 16.8. So it is 7.2. 7.2 volts. So you have your E1, E2, and E3. Now let us place them in the given problem so we could solve for the currents. Okay. So your just move the loop. Okay, I'll just erasing the loop muna. Okay. So your E1 is equal to 1.2 volts. Your E2 is equal to 7.2 volts. And your E3 is equal to 16.8 volts. Okay, now solving for the current, we have 1.2 divided by 3. I think that's 0.4 to be sure. 1.2 divided by 3. Yes, that is 0.4. So 0.4 amperes. And here it's 7.2 divided by 3. That is equal to 2.4 amperes. 2.4 amperes. And finally, your I3, wait, 6 ohms was erased. Okay, so just write it back. 6 ohms. Okay. So it is 16.8 divided by 6. So that is 16.8 divided by 6. So that is 2.8. Okay, so let's see if we're correct. Okay, so if you check the loop, it is 18 minus 1.2 minus 16.8. Okay, since E1 is 1.2 and E3 is 16.8. So that's 18. So if we subtract, you get 0. Okay, also here, 24 minus 7.2 minus 6.8, that is equal to 0. But the best way to check it is using the current. Okay, so dapat I1 plus I2 should be equal to I3. The two currents entering is equal to the current leaving. Okay, so these two are valued at 0.4 amperes and 2.4. So papasok sila. So you add them, yung equality, mag-equal sila to I3. So I think that's correct. 2.4 plus 0.4, that is 2.8 amperes. So you could check the other solution for branch current if we get the same answer. Okay, so you could select with the branch current method or with the node voltage analysis. So your voltage here, your VN, EN is equal to E3. So yung node mo rito. Okay, so you could check the other solution. So hopefully you understood the solution. If not, you could watch it again, okay, for you to understand where the values came from. Okay, so I think that's it, and hopefully this video helped you in analyzing this type of solution. So that's it, and have a good day. Bye.